Hello, everyone, and welcome to today's mini lecture. This is a continuation of the mini lecture that we finished about acids and base, or just acids. What I'd like to do in this mini lecture is address bases. Now, we've talked about IDE being the ending that represents a binary compound. There are two exceptions to that, and if we look at our polyatomic ion table, you'll find out that there's a polyatomic ion called cyanide, and there's one that's called hydroxide. Well, those are the two exceptions to the IDE rule. You just have to pay attention and make sure you identify them, and then you shouldn't have any problems. So these bases are going to be named following the rules that we learned about ionic compounds. So no difference, except you just need to realize that if you're dealing with hydroxides, OHs, then you are talking about a base. So I would like to go through and just demonstrate following the rules for ionic compounds. So when I look at this, it says magnesium hydroxide, but you got to realize this is hydroxide, which is a polyatomic. So I look at my polyatomic ion table, and I know that its chemical symbol is going to be OH, and its charge is -1. So step number 2 says look to see if this element here is a transition or heavy metal. I look at it, main group element, so therefore all I do is write the symbol for each one, Mg for magnesium, OH for hydroxide. Step number next is to go through and look and do their oxidation states. So magnesium is in the second column, therefore it's going to be +2. The OH is going to be -1. So when I crisscross, I'm going to take the 1 and put it here, and the 2 and put it here. So I'm going to write this incorrectly for just a second. And this is the most missed on all of nomenclature, is when you have a hydroxide or a cyanide, you got to remember that it's still a polyatomic. So the way that I wrote it like this is that I have a magnesium, an oxygen, and 2 hydrogens. That's not correct. Instead, this is a polyatomic, so therefore it's going to be in parentheses with a 2. Now I have 2 of the hydroxides. So I'm going to come back down and do the next one. I look at it. Again, it ends in hydroxide, so it is a base and a polyatomic. The first element, the metal this time, is a transition. What does that mean? It just means that the oxidation state or oxidation number has to be given to you, and that's a Roman numeral. So iron is going to be Fe, hydroxide is OH. Since this is a Roman numeral 3, the iron is going to be a +3 oxidation number, a -1. So again, I'm just going to crisscross, and I get Fe. I don't write the 1, and then parentheses OH3. And that would be iron 3 hydroxide. So as we come across and we look at how do you write the names of them, it's same thing, just the opposite. So I'm going to look up here, and I notice right off to the bat that it's a polyatomic and it's an OH. So I know that OHs are hydroxides. So I look at my metal and I say, is this metal a transition element? And sodium is in group 1. Alkali metals is not a transition, so therefore I don't need a Roman numeral. If you don't need a Roman numeral, you just write their names. So this is sodium hydroxide. All right, nothing to it. So the next thing I want to do is I want to look down here at this final example. Again, we have a OH, so it is going to be a hydroxide. It is going to be a base, but this time, look, we have a metal, copper, that is number 29, and it's going to be considered a transition metal. So if we have transition metals, we have to find what that Roman numeral is. To do that, simply do a backwards crisscross. So we're going to spread our compound elements out. You can see here's the metal and the nonmetal. That 2 came from here, and that 1 came from here. So that's going to be a positive 2 because we know all metals lose electrons, therefore they become positively charged. All nonmetals gain electrons, that's a negative 1. So what is the oxidation of my copper? It is going to be 2. So I put COPPER, copper, Roman numeral 2, hydroxide. And that is how we address these. So when we're doing bases, nothing changes from our original rules for the ionic compound. We just have to be careful to make sure that we realize that hydroxide, even though it ends in IDE, is a polyatomic, and we have to find it on our polyatomic ion table. So I hope that that's going to be helpful when y'all fill out your practice problems. If you have any questions, just let me know. Thank you.